Hi everyone, and welcome to the benchmark review for our benchmark tomorrow. Our benchmark tomorrow is on transformations, all four types: reflection, rotation, dilation, and translation. And then we have Pythagorean theorem as a review on our benchmark. So for the question number 1, it says, what would the orientation? Remember, orientation means direction. So it says, what would the direction of the figure L, so here's figure L, after a translation, so that's just a slide, of 8 units to the right. So if I take this letter L, and what happens if I take that letter L and I move it so that it goes over 8 units to the right, 1, 2, 3, 4, 5, 6, 7, 8, and then up 3, 1, 2, 3, then I can use this as a guide. And the orientation says, what would the orientation be? It still stays that letter L shape. It doesn't turn. Remember, orientation is direction. So this is still going to stay in that same L format. It doesn't flip over, it doesn't reflect, it doesn't rotate, and it doesn't rotate that way. So the correct answer for number 1 is indeed C. Number 2 says a figure is reflected over the y-axis and then lowered 6 units. So for this, you really want a piece of graph paper. I don't have the graph paper, so I'm just going to do a pretend graph over here. And it says figure A is reflected over the y-axis, so here's the y-axis, and then lowered 6 units. So notice that all of my original points are x, y, so that means they're going to be in quadrant 1. Remember, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we're going to start in quadrant 1, and it says if I were to reflect it over the y-axis, so we're going to reflect this over to here. So if this was originally xy, when we reflect over here, then this ordered pair is going to be a negative x, comma y. And as soon as I do that, and the reason why is because it's negative on the x value and up a positive y. So right away I can go over to my answers here, and I can look to see the first part of the the first part of the reflection or the problem is we reflected over the y, so the x becomes negative x and the y stays the same. So I need to find where x becomes a negative x and y stays the same. So in doing that, we can get rid of A and we can get rid of C because our x needs to be negative. Then it says we're going to be lowered 6 units. So then we're going to take this and we're going to go down 6 units. So that means there's a change in the y-axis because we're changing in the height. So then that means if it's a change in the y-axis, the correct answer has to be B, because the x stays the same and we're changing. We're not going left and right when we translate down, we're just moving down. Question 3 says, what quadrant would the triangle be in after a 90-degree rotation counterclockwise about the origin? So the good news is this is about the origin. It's the easiest type of rotation to perform. So if I'm going to rotate 90 degrees, remember 90 degrees is every time you jump a neighborhood, quadrant 1, 2, 3, 4, every time you jump a quadrant, that's 90 degrees. Rotation 90 degrees counterclockwise. We have to remember what counterclockwise is. Counterclockwise means we start here and we go in this direction. So we're going to go counterclockwise about the origin. So then it says which quadrant would it be? So if it's all in quadrant 3, when we rotate it counterclockwise, it's going to be in quadrant number 4. So when it goes to, it'll be in quadrant number 4. So now column number 2. Column number 2, so let me get the L out of the way. Column number 2, number 5, says, which of the following is not true? So we're looking for something that's false. Of a trapezoid that has been reflected across the y-axis. So again, here is a graph. Now I could have a trapezoid anywhere in here to start, but we know we need to reflect it across about over on the x-axis. So that means if it was up here, it's going to go down. If it's down here, it's going to go up. And when we reflect over the x-axis, remember that if the point was up here to begin with and it ends up down here, the only thing that point changes is the height. So if it only changes the height, that means the y value is going to change. So that's just things I think of right away. So let's just figure out which ones are false. So let's go through them one by one. Letter A says the new trapezoid is the same size as the original trapezoid. Well, let's see. When we reflect, we never ever change shape or size. So that one is actually true because it does stay the same size. Part B, the new trapezoid is the same shape. That is also true as the original trapezoid. Remember, when we rotate, reflect, and translate, the exact same size as our pre-image, our image will be. The only one that changes size is dilation, and even then it still stays the same shape. Letter C, the new trapezoid is in the same orientation. Now, orientation, remember, is direction. So let me think here. So if I decide to draw a shape, and that shape looks like this, so let me put in the y and the x-axis, and I were to put a letter in here. Let's look at the letter maybe P. And then it says that we're going to worry about the orientation. Now, if we reflect this across the x-axis, remember that's this axis right here. So that means P prime would look like that. So now I look, the direction has changed. Originally P was a P, but now P is a B. So this one is the one that is false. It does not stay the same orientation. Just to be sure, we look at part D. The x-coordinates of the new trapezoid are the same as the x-coordinates of the original. So let's take a look. If I picked this point here, my x value is still going to be the exact same. So this x comma y will be the exact same as this x, but the only difference is that it's going to be negative y. So the answer is letter C. Then, let me get this out of the way. Then number 6 says it. So for this one, we have a triangle with coordinates 6, 4, 2, -1, and -3, 5. It is translated 5 units to the left, and then it is rotated 180 degrees about the origin. So we're going to draw the y and the x-axis, and we don't have to draw all the points right now, but let's try one at a time. So 6, 4 is over 6, 1, 2, 3, 4, 5, 6, and up 4. Just get a ballpark idea. So that's going to be 6, 4. And then it says it is translated to the left 4 units. So if I bring it to the left 4 units, that's going to end up at 2, 4. And when I get 2, 4, I see it here. That is a distractor because I've only moved it once. I've only transformed it once. This is a double. This is a translate, then a rotate. So once I move that to 2, 4, I'm then going to rotate it about the origin 180 degrees. So it doesn't matter whether I go this way or this way. If this were 2, 4 over here, then over here it would be 4, 2. Then down here it's 2, 4. And then over here it is 4, 2. Back to 2, 4 again. So remember, we move around the origin, flip-flopping the numbers in order to get that circular motion because we're changing our length and our width each time. The only thing is different is that this is a negative positive neighborhood, this is a negative negative, and this is a positive negative. So I need to take that 2, 4, over here would be 4, 2, and down here would be 2, 4. But because I'm in quadrant neighborhood 3, they're both going to be negative. So that means letter D is going to be the solution. And I don't have to do the rest if I don't want, because the only one that has -2, -4 as one of its points is letter D.